The 285 linear meter long by 7.5 meter width Jalandoni Flyover is another pilot project of the Department of Public Works and Highways, President's Bridge Program Office under its Mega Bridge for Urban and Rural Development project. The flyover uses modular steel technology from Matier SAS, bridge supplier from France. Located along General Luna Street, intersecting Jalandoni Street and Iloilo City, the flyover aims to decongest traffic in one of its busiest intersections. 37,000 vehicles are crossing the said intersection in a 12-hour period. This is equivalent to an average time delay of 4.18 minutes per vehicle. Design work for the substructure began with soil tests wherein drilling and soil sampling to depth of hard soil strata was conducted. From this test, type of applicable substructure will be determined. Detailed design of substructure then follows. Incorporated in the design loads include superstructure loads provided by superstructure supplier. The finished product is a complete set of design drawings approved by the DPWH Bureau of Design. Also, included in preparation for construction is the conceptualization of traffic scheme that will address traffic congestion expected during construction. Traffic on site is rerouted according to the work phase of construction. Another important consideration is the relocation of affected service facilities, like overhead and underground wires, electrical posts, underground pipes, and drainage canals. Road widening on both sides of the flyover is carried out prior to construction to provide traffic access during construction and also after construction. Upon completion of all necessary preparation, a site coordination meeting between the implementing agency, PBPO, LGUs, NGOs, and other concerned parties will be conducted to ensure the smooth and safe implementation of the flyover project. These includes bar chart schedule of works. Construction's duration varies from site to site. In this case, duration is maximum of 6 months. With all preparation carried out for the start of works, construction of Jalandoni Flyover commenced after the groundbreaking ceremony by Her Excellency Madam President Gloria Macapagal Arroyo. Board pilings work was done through a specialist board pile subcontractor. Work started in the fabrication of rebar cages for the board piles. Drilling works was carried out on pile location based on computed coordinates. Rebar cages are then lowered into the borehole and set to specified levels. Concreting using concrete designed mix followed. Take note that concreting must be carried out at least 4 hours after drilling to prevent cave-ins. These procedures were repeated on all board piles. PDA test on the 3-pile location was carried out after the concrete was cured. A load in a certain height was dropped directly onto the test pile. Measurements were made to detect movement on the pile. If no significant movement, pile can be concluded to have attained its design capacity. Construction of the pile caps followed the successful testing of the board piles. Rebar installation, setting of the anchors to specific levels, fixing of forms, and standard concreting procedure were carried out. It took 7 days to complete one pile cap. Upon completion of the pile caps and abutments, and having attained the concrete curing period, substructure is now ready to receive the superstructure. Superstructure were transported by LCT vessels to the nearest port. It was transported to the laydown area near the site using 40-footer trailer. Delivery of the superstructure is simultaneous with construction of the substructure. Modules are then laid out on the yard according to erection sequence. From there, SIT inspection team convened to check the shipped materials visually as to quantity and the specification. If there are items missing, it will be reported to the supplier for immediate shipment. Assembly of minor members like rail posts, wind bracing, splice plates were carried out on the laydown area prior to transport of modules to site. Actual superstructure installation began with the installation of columns. Columns were set to correct elevation by adjusting the knots on the anchors to specified levels. Shields were provided to transfer load temporarily to the pile cap during erection. Columns are lifted into position. For lower columns, forklift was used. However, crane was used on the higher columns at piers 2 and onwards. The movable anchors facilitated an easy installation of the columns into anchors to correct level and alignment. Installation of the header beams preceded installation of the columns. It took only 2 days to install the columns and headers. Prior to the heavy lift, Matier SAS conducted safety training seminar which resulted to zero harm and injury throughout the erection of the superstructure. Modules are then brought into site and according with the labels and erection sequence. Temporary packings are laid out on the ground, elevation of which corresponds to the camber of the modules when connected. Using one crane, the first module was lifted on the top of the temporary packings. Second module followed, connecting it to the first module through the splice plates. Bolts were installed and manually tightened. Third module was lifted next and connected using the same procedure, thus completing the first line of modules. Then, final tightening procedures on the bolts were carried out using impact wrenches, followed by using high torque wrenches. Second line of modules was assembled on top of the first module to attain the same camber. Third line follows the second on the same procedure. Lifting of the 3 line of modules on top of the columns comes next. First line of modules was lifted using a tandem lift of an 80-tonner and a 60-tonner crane. Sequence of lift and positioning of the 2 cranes were all in accordance with the approved method of lift. For this flyover, beginning at span 2 and onwards, Line A was first lifted into position, followed by Line C placed on top of the already installed Line A. Line B is then lifted and installed into position. Cranes then lifted Line C from Line A and then installed into final position, completing the whole span. Procedures was repeated on the next span and onwards, connecting the span through the articulation pins. Lifting of modules took 2 days for every span. Modules were aligned using jacks from beneath to attain an even road level. Final tightening using the high torque wrenches followed after aligning the decks. Installation of the railings followed installation of the modules. Railings were installed aligned and in sequence in accordance with the drawing. During the erection at span 4, the Honorable Assistant Secretary Emil K. Sadain visited the site to ensure safety and speedy erection of the superstructure. Other works done to complete the flyover after superstructure erection are placing of asphalt overlay on the approaches up to road tie-ins, installation of New Jersey barriers, painting of piers and abutments, and all necessary line markings and signages. The flyover is now ready for traffic. It can be concluded that traffic congestion will never be a problem again at General Luna Jalandoni intersection. Thank you very much to the President's Bridge Program.